we'll go ahead and get started while some last-minute folks join in. Hi, everyone, and welcome to today's presentation, Navigating Data Lineage and its Impact with Interactive Visualization Maps. Today, we have Irene Polikoff. She's Top Quadrant CEO and co-founder. Irene will be presenting an overview of what people mean by data lineage, why it's important to business, and what capabilities are needed to support lineage to be effective and valuable for data governance. We also have Ralph Hodgson. Ralph is the CTO and co-founder of Top Quadrant, and Ralph will be giving a demo to show what's involved in going beyond just lineage visualization to providing effective capabilities for exploring key concerns of data governance with lineage. So before we get started, let's take a second to review a few logistical items. Please feel free to ask questions as we go along by using your GoToWebinar controls. To post questions, please click on the right-hand side control panel, and you should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during the presentation, and we will address as many of those questions as allowed at the conclusion of the webinar. We will also be recording today's webinar, and we'll share a link to that recorded version as well as to the slides. With that, I think we could go ahead and get started. Irene?
Thank you, Christy. So today we will be talking about data lineage. And let's start by defining what data lineage is. The simplest definition of data lineage that it includes data's origins and how it moves across applications. Enriched data lineage also includes a lot of contextual information about data. For example, a connection between data element to some business glossary terms, information about various enterprise systems that process data, exactly how it's being processed by those systems, such as what type of transforms happen, etc. It could also include information of who is using the data, specific stakeholders, the quality of the data, and so on. And in today's webinar, that's what we will be talking about, this enriched concept of data lineage with all the surrounding information. When we think about the physical analogy to data lineage, what comes in mind is road infrastructure. Data moves across applications, roads through digital highways, if you would, and roads provide infrastructure for moving physical things. And as you could see on this picture, when we zoom in to a particular segment of the road, we see a lot of context, a lot of surrounding information, the buildings and infrastructure that surround the road, the fact that it's elevated, how many lines on the highway, and so on. And that kind of level of details is important for certain use cases. But probably the most common one, or the one that many users would want to start interaction with, is a high-level view of the road. So here we see a connection between New York and Los Angeles, and we know that the journey is possible. We could see roughly the length of it and some points from which it goes. This kind of a high-level view for looking at the map display is also important for data lineage. For example, business stakeholders, when they look at lineage, they're looking at it at a high level. They may want to know, okay, employment records, what applications are involved in processing it. And that's a fairly high level view. Now, there's a lot of details behind this view. And as we zoom in and explore, those details become important. Like in case of roads, you could see twists and turns and elevation. You may see information about quality, or some hazard that has happened. You may see information about who is using it, luckily these animals know to use the right side of the road. But this is very akin to what happens with data lineage. For example, a technical stakeholder or any user interested in more details may see, okay, well, this application processes data, but exactly how? Or, what server does this application runs on? Or if we're talking, or exactly what program within the application performs the transformation and what is the nature of the transformation. So some unique challenge in data lineage is this ability to see a high-level view and yet drill down to lower-level details where the details are available. Speaking about, where the details are available, similar question is, well, how much do we capture? Because there's a lot of context, a lot of possible additional metadata. And the answer typically is, well, that depends on your needs and your use cases. And it also doesn't have to be the same throughout your infrastructure, the same throughout your data ecosystem. In some cases, information is more critical, so you may want to have a lot of in-depth details. In other cases, you may only have a high-level connection, what we are calling a logical data flow, where you just know that some information object is moving across applications, but you don't necessarily know all the details. The important point is to be able to connect across this overall landscape, and then details can be provided where needed, and details can also be added over time. So initially you may start with a high-level connected view and then bring in more and more details as you move on for the information where having those details is important. So the nature of your initiative, the scope of your initiative determines how much metadata you will bring in. And that could change over time. And Top Right Edge provides you flexibility for doing this. So let me turn to specifics of today's demo. The demo will happen in two parts. And in the first part, we will talk about demonstrating working with lineage graphs and derivation maps. These are the views that provide more details. For an example from the financial industry that has to do with reporting to the Federal Reserve Board about assets for sales and held to maturity assets. And then in part two of our demo, we'll look at more abstract examples that show various additional capabilities of the lineage tooling, its display and visualization. Now, turning to example in our part one, this is an example of data lineage for form FRY9C, and that's a report that financial institutions such as savings and loans banks, just domestic banks, security holding companies, and so on, provide to the Federal Reserve Board. It's provided in the form of a balance sheet, an income statement, and detailed supporting schedules. You could think about it as somewhat akin to your tax filing, except that this is for a company, so much more complexity as opposed to for an individual. And the goal of it is to monitor the health of financial institutions. We're using this report as a compliance example, but actually the same kind of lineage requirements would apply to other regulatory reporting forms, such as GDPR. This is a data protection regulation from European Commission, or CCCAR, which is another Federal Reserve compliance requirement. Okay, this report, Y9C, has a collection of schedules and a number of supporting schedules. You see them on this slide. And for this demo example, we will be looking at schedule HCR. And this schedule is important because it's about how well institution is securitized. And of course, for a financial institution, if it is held accountable, then it needs to be able to know that the number is correct. And in fact, it needs to be able to prove to the federal government that they have mechanisms in place to ensure that this is a correct number and they know where the number is coming from. So we'll show you today how Top-Rated Edge could help trace the values that are being reported and to prove where they come from. In the schedule, there are many calculations, and so it's a fairly complex requirement to bring information from different data sources to report on those values. How it all works is that we see here in where the form or report is being specified, each item on the report is referred by something called MDRM item. And MDRM stands for Microdata Reference Manual. So there is a data dictionary or manual from the Federal Reserve where each value on the report is described. In this case, it's BHCK S490, and we could see all those individual data elements and forms are actually represented in Edge, and this value has to do with total on-balance sheet securitization exposure. All the definitions are connected and description of the report is captured, as well as the lineage and information about where this actual data comes in to fill out this field on the report. So in the demo, we'll be tracing from the line item that is reported on the form to the actual the applications and data elements that come into play to compute that value and to put it on the actual report. So with that, you could also think about it from the perspective of a high-level view, as we discussed, as well as a detailed view. In the demo today, we'll be starting with a high-level view, and then we will be drilling in more details of specific applications involved, specific program modules that are involved. What you will learn is how a business term from the SEC, or Security and Exchange Commission glossary, can be mapped to the data elements or to the technical assets such as software programs. How a starting point for the lineage exploration could be either a field in the report or a business term or even an activity that requires this information. In this case, the activity would be regulatory compliance, for example, but it could be any kind of activity. And in a more general sense, you'll also be introduced to navigation within, to and from the lineagegram, drilling down to details that are presented on so-called derivation maps. And here in the screenshot, you see the lineage diagram. As you could see, it can be quite complex and condensed, and more details on the derivation map. And you also see some navigation within and from a derivation map. And with this, we're going to pass to Ralph for the actual demo of this part.
Thank you, Irene. I'm unmuted, I think, and I am asked to show my screen. So I shall ask for a confirmation that I can be heard and indeed my screen can be seen. Is that the case? Just need to hear from Christy. I'm assuming
I can see your screen. Yes.
Yeah. You can hear. Okay. Very good. We start with the screen that you see. Default screen in top right edge is organized into a number of areas. There are some general things here. Then we have this notion of asset collections, and this covers some of the things that Irene talked about, but more of the things that she didn't talk about. And that is because our asset collections are also extendable. And we have, for example, e-health assets here. But what I'm going to be focused on when I work with you on this demo is the lineage models. And they pull in things from glossaries, they pull in things from technical assets, and in some cases from reference data and from ontologies. The whole tooling is based on knowledge graphs, and it uses W3C, World Wide Web Consortium technologies to do the inferencing that you will see happening to give this summarization or high-level view that Irene spoke of. So one place that we might start is actually just to pick up on what Irene was talking about with this S490. So when I go to S490 here, I'm actually using a simpler Google-like search where I'm looking for that occurrence. And I see that indeed there is a BHCK S490 item here, a data element. It's a form item. And I have various icons here that will let me explore it. This is a neighborgram, which gives me the immediate connectivity of this thing. This is a graph of what we call upstream or lineage information. And this is a graph of downstream or impact. And if we go first of all to the lineage, which is what I'm doing now by clicking on this, we'll generate a lineage model over quite a number of things here. And this now it's just going to summarize the view. I will make that a little bigger for you to see. And what we see here, that this is the element or the form item. There is a edge to it, which is a summarization edge. And the summarization can be opened into a derivation map. We go upstream to an application, which will hold a program that is responsible for making the data that this is, yeah. And then we see another connection going upstream to another application here. We see that we have a securitization application for assets for sale. Looking at this one here, we see we've got a hold to maturity application. These two applications are dependent on data from a top bank corp database and a securitization database. And that's what we mean by the high level view, the ability to take the complexity of what's going on, present it at the highest level where not only a business user would be comfortable with this, but also the IT people can get a handle on what they're about to drill into. One of the examples of drilling into things could be to click on a data input. This is a D with a little box on the side, and the derivation map is generated like this. It's showing, let me just make it possible to open this up a little bit so you can see the columns. And we see that there are several columns here. I needed to zoom a bit more, which have to do with this application, which is running a program. So we see that it's a program that is within an application. That's what we see by this box. Let me close this down so we can talk about some of the other links. We see that it complies with the policy requirements. So there's an aspect of these columns that we were also getting a summarization of at this level. We can drill further into that as we explore this. This red link will allow us to drill even further. There's a backup policy as well here. And this thing also happens to have PII. The category of PII is sensitive data. Its use is implied by contract as opposed to requiring the data subject to indicate their consent. And the obfuscation is using this method of pseudonymization. So this is what we mean by a derivation map, the ability to have a way to drill down into the details and not clutter up the first picture with all of this information. The management of this complexity requires us to have a number of new visualization gadgets that are really less about diagramming, more about navigation and inferencing within the diagram domain. Yep. And this is actually a new trend in the diagram technologies that people are pursuing, and we're taking good advantage of it. So that was the first part of describing this. We might want to go and look a bit further at what's going on between applications. And so we click on this link and we find ourselves looking at a summarization of two applications. This one is depending on data from this application, and the dependency is actually described here in terms of, represented here in terms of the columns that are involved, and we get to see which programs are busy here by opening up these links. And we see there are outputs and we see there are inputs going on the other side. So that's an example of what we call an S or software program dependency. There is another lower level dependency we can abstract and summarize in a link like this, and that is a transform based on functions that are provided by SQL scripts and ETL scripts. We're not going to go deeper into that at this point. There is another thing to discuss here in the ability to drill down on an application and see what the story is from this point. So when we click on this icon, we're achieving a drill down. And the drill down shows us that we're busy with an application that's producing these BHCK items, and when there's more fan out than we can hold, we have continuation nodes that I'll discuss in part 2 to deal with the scalability of the picture in that manner. Just as a sidebar, the way that the ideas that you're seeing here were from computer-aided design layouts, printed circuit layouts, things that have a very stylistic and algorithmic approach to layout, and that's what you're going to see more of that as I proceed. Maybe I show you one aspect of it now, and I put these into frames. We can see that if I close this frame, I'm looking at an off-page connector at some point. This is typical of an engineering drawing where I can travel to an off-page connector and open it up. So these kinds of navigation mechanisms are important, not only to the CAD world, if you're designing chips, silicon chips, but also to the world of data governance. Yeah. I go back to the full view by clicking this, and we have another drill down to perhaps look at, and this is the business activity. If we were starting our search from here and wanting to know the lineage of this, we could achieve that in the same manner by clicking on this icon. And here we are computing the lineage of this business activity in a high level. I should explain to you that the parameters that control this have two particular parameters that were involved there. One is the notion of reach, and the other is the notion of breadth. What we mean by breadth and reach, let me just make this picture a little readable. Yeah, that's probably fine. What we mean by reach is how far up the lineage chain we go, and breadth is how many fan-ins do we consider at any one node? How many incoming connections do we limit the search to? And that is an important way to limit things. Yeah. So this is the business activity. Then it's produced by a lineage model here, which is contextualizing, giving a context for this to do its lineage work and find the applications. We're also depicting the direct reports that this thing is busy with. So we see here another kind of link where we have a representation of this activity requiring this information asset. This could be extended to talk about more of the business context and the stakeholders that might be involved in this, so we can reach further into the enterprise. So that's the business activity viewpoint. We can go back by clicking on this back arrow taking us all the way back to the very first diagram here. I'd like to return to search the edge now and look for something else. I could do it here by taking this out, but I'd like to do it by starting here again. And I want to perhaps search for another thing, which would be the impact diagram. I should have perhaps stayed on the 490, but I'm going to get it again. But there's a different order in which I might have done something here. But I've chosen to go back to S490 and describe this other icon. We were looking at the upstream. Now we look at the downstream. So this is the traceability from S490, and this picture is depicting the. Let me bring it into view, and maybe, yeah, that's fine now, I think. Yeah. So we see S490 here. Its impact is described by the outgoing links. It's got an impact to the business activity here. It has an impact on the securitization model. It has an impact on this application, sorry, this program, Scala 1 program. And the reason it has the impact is that this program is producing it. Yeah, so that's what the green line means. It means I'm both an impacting element, but I'm also an output of the things that the reason that I'm impacting this is it's an output. Yeah, and we of course impact the business activity here. With this arrow, we show that, and we can see a summarization of this by saying that by showing that the 490 element, which is part of the schedule HCR, is required by this business activity. So that was the inference over the knowledge graph that led to this creation of this link here. So I'd now like to go back to show the search again, and perhaps explain the more icon. Irene showed a picture of this screen, which is showing the details of this item. And if we were to want to look at this on the web, I would want to go to the reference link and open it. I think I can go to it this way. Yeah. And this takes me to the Fed and directly to the data dictionary, which the Fed puts out here. The Federal Reserve Board is putting out in in CSV kinds of formats. When you download it, you don't get a knowledge graph. So we've had to convert the 6,000, 7,000 things that are here into a knowledge graph expressed in RDF. Yeah, so that's present for every one of these items. We can click on the link, as you saw me doing. We can see the effectivity dates. We can see the same kind of information that is present on that web page, but this now in a machine processable format. So that was the search the edge for the item. We might also want to search for the form item. We also might want to search the edge for other things. And let me do it here for AFS. What does it mean to say AFS? Well, it occurs as a glossary term. It occurs on all of these models. And when we see it here as a glossary term, we get a new kind of icon, which is looks like a road, and it's the impact diagram, or sorry, usage diagram that we'll now be looking at. This diagram is one that connects to the data elements directly. We don't show beyond the first level of impact because this can get very busy. And each of these things is a T link, a T with a, let me show you that link better by, I think you can see it now with a T with two arrows on it. If we search, typically we'd probably search for customer or something like that here, and we go to that, and we can now decide to drill further, to change the focus node to that, and we now see the impact that this customer ID element has. And what that gives us is the ability to explore new things again. We can go and look at, for example, at this connection. This is a data derivation map, data output, the box being on the right there. This data output is telling us that we have, I think we saw this earlier. It's the same kind of thing that we saw with, no, we didn't see this one earlier. This is showing the dependency between two applications, and they depend on a couple of columns here that belong to a table that are held on this database. If this database server was known, we would show that is another link in a box in this picture. Yeah? So we are not seeing any PII here, so that's not going to appear in the diagram. If there were policy things, we would see those in the diagram, but in this case, there aren't any. So that's what happens with the traceability we can have on impact right from a glossary term, AFS security, to a particular database column. Let me make that a little bigger, expand that, and maybe we can see it also in the frame view a little better. I'll go there in a second, but this is showing the impact that one program has on another, all the way down to a business activity. Now, is it interesting to collapse all of this into a way that we could say, well, I only want to know what the impact of this is on business activities? And the answer is yes. Those kind of end-to-end searches can also be done to collapse all this picture into one box, and then you click on the box and it reveals its inner structure. Yeah? So let me see what time we're looking at now. Yes, we have another part 2 to do, so I probably have to pass back to Irene very soon. But this view here, where I was showing the off-page connectors, like this guy, we have the ability to drag it in, or we have the ability to which I can't show anymore, but which I will make possible to show. Let's do it on this guy. This guy is connected off here. If I click on it, it brings in the other pane. And we have scrolling within these panes, so there is a management of scalability in these panes when the picture gets quite complicated. And that combined with search and filtering gives you the ability to restrict your view of the whole ecosystem. Irene, I think I should pass back to you now.
Okay, thank you, Ralph. I'm just gonna briefly introduce the second part of the demo. So in this part, we have seen the lineage for the reporting items on this Fed schedule. And we already saw a number of mechanisms for navigating, zooming in to see more details. We also saw that the links between the objects that are shown on the lineage graph can be of different types, showing data flow, functional flow, information object flow, and so on. Ralph has mentioned that lineage view can get quite extensive and complex, and brought up this concept of fan in and fan out, which is essentially about the breadth of display in a lineage graph and how it could be controlled and how you could page to see more fan in or more fan out. And that's what we're going to show in this part 2 of the demo. And we'll also show how you could extend the reach to see more hops in this lineage connection, so more upstream and more downstream type of the thing. Lineage graph is quite a sophisticated tool with many mechanisms. So what you will learn in this part 2 of the demo is how it manages the display of a long chain of upstream dependencies, which we mean when we say reach. And as you could imagine, in a typical enterprise, lineage is complex. So being able to do that is important. And also how this number of incoming and outgoing connections can be constrained. This is what we mean by breadth. As I mentioned earlier, we'll use somewhat abstract examples. We just say, application 900, data source 1000, etc. So with that, I will switch back to Ralph for that part of the demo.
Yeah, thank you, Irene. I've just unmuted myself, which showing screen again, and as Irene indicated, I would be using a test suite. This test suite is called LM tests, and there are a number of lineage models here. The first one I want to go to, let me think about this, more upstream, I think, is where we should start. Yeah, so we click on this lineage model and we ask for its lineage, and we see in a picture that is quite busy. I will again make it possible to see. This is, I don't know if I go in there, you can see that there's a more upstream icon, and we start from this lineage model anchor, and that anchor takes us up a chain. We've gone 10 steps, and we've run out of reach. Yeah. So when we click on this guy and we say, well, tell me more, yeah, it'll generate a picture that is like this. If I just provide you a better view of that, so we pick up the story again with. I want to click. Yeah, that's fine. We're picking up the story on 9026, and it's going out a few more steps to 9029, and on the frame view we don't see anything more. Yeah, that's fine. So going back to this, we can actually we've shown the frame, so I won't go back and do that, but I will go back to my lineage models, and we should perhaps show the more fan-in now, I think. Yeah, so more fan-in is a similar notion, and here we have a lineage diagram that presents us with similar kind of depiction. Notice that when we click on a node, it grays out the other nodes, and the filter mechanism will also do that. I'm choosing to illustrate this by mouse clicks at the moment for the limited time we have. So here is a more upstream icon, and as you might imagine, what we're going to see is picking up the story of what else is giving input to this node, and we do that again by changing the focus nodes. So here we see not too many new things, this app and this app, and there's a further dependency going on here between these apps. This is a simple, this thing depends on this thing. This is the highest kind of view that you might express when you haven't perhaps gone and run extractors, knowledge extractors on your IT systems. Once we have that imported, we can understand more than simply the direct connection. We can see it in terms of programs and functions. Yeah. So let's look at another kind of thing that people ask us, well, what if it's not only applications? What if it's also people? What if an application produces a spreadsheet, and that spreadsheet is processed by a person, and the person then gives input to an application? Well, we handle that. I think I have it on the data flows, data flow dependencies. Let me see if it's on this one. Yes, this is the one that depicts a person, a salesperson here, and then there's a stakeholder group. We can talk about organizations, we can talk about stakeholders, and we can talk about individual roles in the organization, and we can see what kind of things are going on. It's a source for, but the data flow isn't isn't understood yet. Here it is understood. There's a data flow going on between this application and this application. We can drill down further into that to find out more. We also note here that this is hosted on a server. If it was on the cloud, we would be seeing that information as well. And which cloud technology it's using could also be depicted. We have the extensibility in our models to do all that. So that's human in the loop. One of the other things that is important to realize is not just the physical flows, but also kind of like the human in the loop, there's the notion of logical flows, which is what the business people typically will start off describing. And logical flows are exemplified by this model. These blue lines have an L with a wavy line to it. And this logical flow is expressing knowledge that the business analyst has discovered that there are information types, in this case, individuals, payroll data, resume, personal data use consent. All of those things are being passed from this application to this application. This could be a stakeholder group, or it could be a person. A similar picture would appear. The other thing that's important about this view is the logical entities. This logical entity connection could then be explored for, well, how is this employee represented in the physical databases? And this is an exploration that would take us back to on this link and on these links to other diagrams. So the extensibility allows us to have new kinds of navigations with these icons, and the two that are important here is what we call the fast forward, the trace downstream and trace upstream. But there's also this link here which will take us back into our tool, and we see logical entity, and we can see we could describe it more. We could give it compliance metadata, and then we would see compliance aspects coming into the derivation map. And that hasn't been specified on here. So that's logical flow. I have perhaps time to show you one last thing, which would be the program level dependencies. Let me go to program level I should also cover recursive. So we'll go a little quickly on this one. On program level dependencies, we see this small example where we have the software program dependencies here, but we also have another one here. But we also know of a functional dependency. This is a transform, little t, two boxes, two shapes on either side. I'm going to click on the S shape, and here we see a server that is shared. No, sorry, it's not the server that's shared. This is the only server of this program. This program is outputting data to this database, which is running on this server, and there's a column here that is being picked up as data from this software program. So that's the program level dependency. The functional level dependency would go into, well, what kind of ETL script or what kind of SQL thing is going on? Is it a collect statement, is it a case statement, an if statement, or a simple SQL query that is behind this derivation summarization here? So that is the physical data flow based on program and transforms. I have time to give you the recursive example, and I shall go quickly to that. So when we look at recursion, we are seeing that an application depends on itself. It depends on itself because it has output and input data. We need to separate that with a little improvement to our UI. We could have that happening without a clash, but you get the idea that there's a data element that is input and output to this program, and this program is owned, is what we're looking at, in fact. And if it were owned by a business application, we would see that detail in the picture. So at 12:18, I should probably pass back to Irene and Christy, see if there's any questions. I might have missed one thing, which is another operator. I'd like to just, given I might have a minute.
I think we already switched the screen. So and it is running fairly close to the end of end of our webinar. So let me just summarize. I would just want to make sure that we have some time at the end for questions, Ralph. So let me quickly summarize what we have seen, and then we're going to move to the Q&A session, time permitting. So what we've seen today is that how presentation of the lineage can be done at the various levels and show different aspects of connections between entities of interest. All of this in order to simplify display of this information, make it more accessible, and B, to support different perspectives on different types of information that users may be interested in. So at a very high level, we see how systems interact with data, or how systems and data interacts with business activities and stakeholders. And then in a more granular view, we could see details of those interactions. There is semantics and richer meaning for the connections that is displayed on this lineage map. So we saw the different color of connections, the different icons on the connections, which serve to show data flow view, the logical flow view. Ralph showed some program level dependencies, talked about functional level dependencies, and this level of dependencies is made visible through this iconology and different colors. We also saw a number of different mechanisms or tools for enriching usability and scalability. So basically everything in the diagram knows their space, their place on the map, and we saw how panels could be used. We also saw fanning in, fanning out. We saw this mechanism of filtering the view where you focus on a particular node and then everything else in the map is grayed out and you see only things connected to that. There is something called a gather operation. I don't believe Ralph showed it, but you could also gather immediate nodes, direct connections in this cluster arrangement. So various approaches to deal with complexity, to deal with scalability, and the potentially vast amount of information that could be brought together to show those views. I'm gonna do a very quick announcement and then we're gonna move to Q&A. For those of you who are interested in the technology behind Top Right Edge, behind our tooling that drives all those capabilities, we've been doing some public trainings. This is a standards-based product, and Shackle is a knowledge representation standard. Is a standard for knowledge graphs from W3C, World Wide Web Consortium. The training in New York was last week. And there's an upcoming training that still has some seats available, but it's getting subscribed fairly quickly. It's in the Netherlands, in Utrecht. Utrecht is a small town right next to Amsterdam, so you could think about it as being in Amsterdam. If anyone is interested, go to Top Quadrant's website, and the training announcement is right on the homepage. So with that, I could turn into the Q&A session, and I think Christy will let us know how much time we have and what are the questions that we've got.
Great, thank you, Irene and Ralph. We do have time for a couple of questions, and I see we have a couple coming in, so let's just start here. Question one, you have shown some lineage tracking based on rich models, but how does the data get into the models? Irene, did you want to take that?
Yeah, sure. So there are many ways, actually. Information that's presented in Lineage, when you think about it, it exists in your enterprise. It just exists in various places, and it's distributed across different people and different systems. Often what our customers do, they may have some spreadsheets that they use to capture some of the lineage information, and some go to pretty low level of detail where they describe various transforms of different programs, again, for critical data, for data that's very important to them. At the high level, kind of a logical flow connections, or information about stakeholders and information about business activities. This may be something just that certain business analysts that know. And it may not be captured in any tool. It may be captured in documents and just may be captured in their heads, their knowledge. And information about server infrastructure, etc., may be available in some systems. So depending on the level of detail, the information can be brought in by importing from the underlying sources, such as spreadsheets. I've given an example. If there is data source, we could connect to a data source and get its schema. And there's also tooling that could be used, and some companies have in place, and we have integration with, that can examine stored procedures and find out details of the transformation. So that gives you some technical aspects of the lineage. Business aspects typically get brought in through either import of spreadsheets or direct data entry, because previously to Tab Edge, this information was not captured any place. And then it all comes together in Tab Edge as a knowledge graph that we have been exploring. Ralph, do you want to add anything?
No, I think that pretty much covers it. It's kind of important to realize that the ability to go use any one of these mechanisms is sometimes constrained by what policies an organization has. So we tend to have to be creative about how we do that with existing tools they may have as well. We've been in situations where customers that have bought a data governance product, and I won't name vendors here, but that they want the data in those tools to be brought into our tool. So we're into the transform business, building what we call the nexus. We are perhaps one of the only products out there that can uses standards, W3C standards, to provide a way of connecting the dots across metadata silos. So that sometimes is how we get busy. Yeah?
Great, thank you, Ralph. I think we have time for one more quick question, and Ralph, I think this one might be for you. How do you cope with scalability, both in the scale of the underlying data? For example, a database might have hundreds of columns, and in the visualization of the lineage diagram's extent and detail.
Yeah, well, I hope that we covered, perhaps that the person that asked the question hadn't heard me talk about breadth and reach, but just to go over that again, reach is a way of constraining what we see in a picture. Breadth, how much we see as input or output on a particular node. But there are other things that are important on dealing with scalability, and that has to do with this notion of layers of abstraction. And I think there's probably people wondering how their data, when it's represented, the same physical data is represented in different places and can only be made sense of through a logical model. How do we get the logical model in, and how do we pull those other data in? How does the visualization cope with navigating the relationships between the logical world and the physical world? Well, all of that is there. I just didn't have that in my demo. With these models I showed, the mechanism models, there is one actually I could have gone into to show the kinds of connections that are possible between the logical world and different instantiations of that in the physical world. It needs, of course, ETL parsing scripts. There's two main companies that provide that. We work, I think you've probably heard that we work with GetManta, but there's another company that does similar things, and we encounter, as I said earlier, the need to bring data from metadata silos. So the scalability has to do with being able to recognize distinctions between different kinds of physical data, to partition that, and to organize those partitions into navigatable nodes. And this is where the knowledge on models or ontologies that we have, with should I add some 10-person years of work gone into them, allow us to make those distinctions. Yeah, so we have been busy in the world of enterprise architecture in the past, and we've been busy in data governance for 3 or 4 years, and now it's all coming together with these ideas inspired by engineering world of CAD/CAM. Yeah, so scalability of CAD/CAM in chip design has already been solved. We take lessons from that, yeah?
Okay. Well, I think with that said, Ralph, we are right against the hour, so we've run out of time, but we will be sharing the answers to several other questions that we did receive today via an email response to all attendees, as well as a blog post that we will share. We will also be providing a link to this recorded presentation as well as to the slides. We certainly hope you found today's information valuable, and thank you everyone for your attention and interest in today's webinar. Have a great day. Thank you, everyone.